We're going to look at example 2 in your section 4.6 notes. So we're going to use linear approximation to estimate the cube root of 65. So just a reminder, this is the equation that we're using for linear approximation. It comes from the point-slope form of a line. But in order to do this, they weren't as straightforward as example 1. We have to figure out what is the function f of x and what is a good a value that we could actually take the cube root of. So first of all, our function is the cube root of x, okay? All right, because we can see that from the structure of the problem. So we need a number that we can take the cube root of pretty easily. So I'm going to pick a to be 64 because I can take the cube root of 64, all right? So to write our linear approximation equation, we're going to run through our 3 steps. We first up need the slope, which involves the derivative. Okay, so please remember when you have a cube root, that is like writing your function to the 1/3 power, which might be nice before you take the derivative. So if we drop 1/3 down, okay, and then we're going to go ahead and subtract 1/3 minus 1, we're going to get a negative 2/3 as our derivative there. So now we want to look at the derivative at our point 64, because that'll be the slope. Okay, so we're going to have 1/3, and then we're going to have, remember this is our root, so we have the cube root of 64, and then that's still to the negative 2. Okay, so we have 1/3, so the cube root of 64, the reason we picked that is because it gives us a nice answer like 4, okay, to the negative 2. So a negative exponent just means to move it downstairs with the 3. So we have 4 squared there. And now this is something that we can do. We have 16 times 3. So the slope of our line is going to be 1/48. Okay, now we need to find the point. So far we have the x-coordinate of the point, which is 64. Remember, y and f of x are the same. So we want the y-coordinate, so we're going to take the cube root of 64 one more time, and that goes there. So we have the point complete. Okay. All right, finally we're ready for the linear approximation equation here. So writing the equation of our line, we have y minus the y-coordinate of 4 is equal to the slope of 1/48 times x minus the x-coordinate, which was 64. Okay, just like last time, I'm going to go ahead and replace y with my linear approximation notation here and kick over the 4. So I know the linear approximation is going to be, equation is 4 plus 1/48 times the quantity x minus 64. All right, so that's going to give me a pretty good way to estimate what's going on with the cube root of 65. So plugging in that 65, I will get 4 plus 1/48 times 65 minus 64. Okay, so I have 4 plus, well, that'll just be 1, so I just want to add the 1/48. So you can put it as 4 and 1/48, or you can put it in your calculator. When I put it in my calculator, I got 4.02083, and that's our approximation for the cube root of 65, okay? All right, so here's the thing. Just like in example 1, you know, you should check it. You should put the cube root of 65 in your calculator and see what you get as an exact answer, okay? So when I put this in my calculator, I got a 4.0207, and the approximation that we got from our linear approximation equation is pretty darn close to that, so I can be confident that I did a pretty good job with estimation.